Properties of exponents. Now this is a review from Algebra 1, but we're going to go ahead and review these properties again. The product of powers is when you have the same base that's multiplied together. So when you're multiplying the same base, all you're going to do is add those exponents. So a to the fourth times a to the third is just going to be a to the seventh. So you want to keep the same base and add those exponents. A power of a power is when you have a base with an exponent and that whole thing is raised to another exponent. In that case, we're going to multiply the exponents. So this is actually a to the 14th. A power of a product. So when you have multiple terms that are multiplied and then there's a set of parentheses around it with an exponent, you're actually going to distribute that exponent to each term inside. So this will be 2 cubed, a cubed, and b cubed. And then we can always further simplify 2 cubed. A negative power is when you have a base raised to a negative exponent. Now we always want to have positive exponents. So whenever you have a negative exponent, we're actually going to take the reciprocal of just that term. So this is going to become 1 over a and then raised to a positive 5 exponent. Quotient of powers. When you have the same base on the top and bottom of a fraction, we're actually dividing those terms. And we're going to subtract the exponents and then put your answer wherever the higher exponent was. That way we avoid having negative exponents. So if we draw our fraction bar, a squared on top, a to the 5th on the bottom. We're going to subtract those. 5 minus 2 is 3. And since the bigger exponent's on the bottom, we'll put a cubed on the bottom. Then when you look at b, we have b to the 6th. And remember, this is b to the 1st power. And so we're going to take 6 minus 1, which is 5. And since 6 is the bigger exponent, we're going to put it on the top. So b to the 5th goes on the top of the fraction. Power of a quotient. When you have a fraction inside parentheses and that's all raised to an exponent, we're going to take that exponent and distribute it to each term inside. It's kind of like the power of a product where you distribute that exponent to each term. So we're going to have a to the 4th over b to the 4th times c to the 4th. Then 0 power. This is the easy one. Anything raised to the 0 power is equal to 1. Make sure you know these properties well. We might need to use one or more than one in each set of problems that we have. Let's go ahead and practice simplifying and rewriting the expressions using positive exponents. So here we have one term multiplied by another. So we can take 5 times negative 3 is negative 15. And then a cubed times a to the negative 4th. Remember, when you multiply like bases, you add the exponent. So 3 minus 4 gives us negative 1. But we don't want to have any negative exponents. So that means that this term, a to the negative 1, we need to take the reciprocal of it. So negative 15 is going to stay where it is. And then we're just going to put the a on the bottom of the fraction. And here is our simplified expression with positive exponents. In the second example, we have a term that's raised, the whole term is raised to an exponent of 2. So we need to distribute that exponent to each base in here. So we have negative 4 raised to the 2nd power. We have x to the negative 3 that's squared. And then we also have y 5th that's squared. So here, negative 4 squared is going to be a positive 16. X to the negative 3rd squared, so when you have an exponent on an exponent, you multiply. So this is x to the negative 6, and then again, y to the 5th squared, this is going to be y to the 10th. Now, again, we need to get rid of this negative exponent, and it belongs to the x only, so we leave the 16 y to the 10th on top, and we just move x to the 6th on the bottom. And here's our simplified expression. So in example 3, we have this fraction, and then that whole thing is raised to the negative 2 power. So we need to make sure we distribute that exponent to each term inside. So we're going to have n cubed raised to the negative 2 over p raised to the negative 2. So first let's go ahead and simplify this. Remember, exponents raised to another exponent we need to multiply. So that's really n raised to the negative 6 over p to the negative 2. And then lastly, we need to get rid of negative exponents. So since both of these happen to be negative, we actually need to move both of them. So the p squared is going to come to the top, and then n to the 6 is going to go to the bottom, and that's how we make the exponents positive. And here's our simplified expression. For example 4, there are a few things going on, so let's go ahead and work with this. First, let's distribute this exponent to every term inside. So we have 4 times q cubed, and that's squared, and then r to the 0 power. Remember, anything to the 0 power is 1, so I'm just going to replace that with 1, and that's going to be squared all over 2q squared times m. So let's go ahead and simplify this. We have 4 times an exponent raised to an exponent. We need to multiply, so that's q to the 6th. 1 squared is just 1, and we actually don't need to write that in. And then this is over 2q squared times m. So let's go ahead and simplify one more time. 4 divided by 2 is 2. We have q to the 6th over q squared. So 6 minus 2 is 4. So q to the 4th comes up top. And we don't have anything to do with that m, so that's just going to stay on the bottom. That's it for this review on properties of exponents.